This is a nuclear fusion reaction. It's been a pipe dream of scientists for nearly 100 years, but it's just coming to be now. And with it, a new era of humanity has begun. Hopefully, that's just a theory, but the requirements of a fusion civilization are already clear to us, and what we're going to need is going to turn industries upside down. This is helium-3, a rare isotope of helium that we only know of because of its more explosive older brother, tritium. Despite this, however, this strange little offshoot of a very well-known element has a lot to answer for. In fact, some estimate that just 25 tons worth of the stuff could power the United States for 1 year. However, all fusion reactions generate massive amounts of energy, so what makes this particular one so interesting? First, I hinted at this one earlier, but it's because helium-3 is much less radioactive. You see, one of the major issues with nuclear fission is its toxic waste produced from the reactions. Instead, helium-3 combines to form helium-4, which is quite common but more importantly a very stable isotope of helium. Bring these two together and you can expect a very powerful reaction with very limited radiation. Second, light atoms in large quantities are hard to come by, and wait, I hear you, I just said that helium-3 is hard to find, so what's the deal? In fact, the sun produces literal boatloads of this stuff, so why is the most significant way to get this stuff the nuclear weapons program? Well, it's got something to do with this. That's right, helium-3 is pushed away from us by a big magnetic field, and trust me, the magnetic field's got a lot of positives, but unfortunately, the seemingly perfect resource won't be found anywhere near the surface. And so you've probably long realized the best source of this magic powder is our moon. Our cosmic neighbor has none of the necessary precautions for avoiding the helium-3 carrying solar winds and is therefore littered with the stuff. Approximately 1.1 million tons exist on the moon, and at 4 billion a ton, that's serious bank and serious energy. 2. Extraction. Unfortunately, after we land on the moon, there's a little bit of a process to getting some helium-3 out of the soil. An easy process compared to Earth, but it's a process that you have to execute in space. First, helium-3 can be contained in the surface of the moon down to a depth of about 3 meters. This is due to asteroid impacts spraying up regolith that covers the helium. After collecting this topsoil of sorts, you've got to melt it all, up to about 600 degrees Celsius, which at that point you can put the helium-3 into some jars and send them back for power generation. While this might seem like quite the process to get some less radioactive fuel, it's estimated the ROI on this stuff will be 250 times what you invest. Just one of Elon Musk's Starship carrying this insanely valuable gas, and it becomes worth $600 billion. That's like 2.5 of my country. Re-entry would be pretty simple since the helium isotope is so stable, a normal re-entry process would likely be able to occur. Anyway, before we hop on to the next section, I wanted to ask a question. How should the wealth gained from the moon be distributed? As I touched on earlier, the first company to gain rights on a helium-3 field and start mining will become incredibly rich. Rich on the scale of astro mining, making people like Elon Musk and companies like Apple look normal. Furthermore, any country this company is in would benefit enormously, bringing in tens of billions of dollars in taxes alone. And I won't keep on speculating because I'm no social scientist, but I find the prospect interesting nonetheless. Alright, in this section we'll take a look at what the future looks like if all goes to plan. This is interesting because this video relies on the assumption that nuclear fusion is successful and viable in the future. Thankfully, there are no shortages of companies working towards our fusion future right now. Some big names include Helion Fusion, Tokamak Energy, and General Fusion. If viability is proven and the rewards are great enough for exploitation, I have no doubt countries will have a problem investing in space. Think of the space race, but for the good of humanity instead of the competition of two ideologies. For long, the best locations for mining on the moon would likely be swamped, maybe comparable to events like the Californian Gold Rush. And then afterwards, more regulations would form and bigger companies would occupy more and more of the market. Zooming out for a moment, what would our world look like? Well, it would be pretty awesome. Just about a third of the world's pollution would be knocked out pretty instantly. Fusion engines could propel us around our solar system, making journeys to planets measured in weeks, not years. From then, it's kind of hard to guess the true scale of this breakthrough, kind of like computers in the 40s and 50s. Anyway, let's take a look at a timeline, however accurate it may be. The general consensus among private companies is viable fusion reactors by 2035, and to account for companies' bias, we'll extend that to 2040. Soon after fusion is introduced, if it lives up to the hype, we'll see an explosion in the industry. All of the components and materials needed for nuclear fusion will have increases in demands by orders of magnitudes larger, and that includes helium-3, if that's still the most viable fuel. At this point, rockets like the SpaceX Starship will be going regularly, and the first guy to put some mining equipment and point it at a moon will become a billionaire for sure. In this timeline, we can expect pretty large mining ups around 2050, but 10 years later, we might even be able to match Earth-scale digging. Once the necessary helium-3 is harvested, prices will drop and the gold rush will end. Mining will still continue, but as I said before, it only takes a certain amount of helium to run the world. Whatever happens next, I'll be stoked if it comes during my lifetime. But as for me, that's all I have to say, and I'll see you later. If you subscribe now, by the way, you'll become like my 97th subscriber.